Morning students, today we are starting off with a new chapter, that is atoms and molecules. The question arises, what are atoms? We know atoms are nothing but these are small particles or tiny particles that make up matter, and it is the atoms that combine together to form molecules. Example of molecule would be H2, N2. So these are all molecules. We see N2 is made up of nitrogen atom, H2 is made up of hydrogen atom. So these two are examples of molecules, and there are many more. The idea of divisibility of matter was considered long back in India around 500 BC. It means the matter could be divided further. This idea was considered long back or was known to man about around 500 BC. It was Maharishi Kannad who postulated that if we go on dividing matter, we shall get smaller and smaller particles. He called these particles Paramanu. Now we know these Paramanus are nothing but atoms. So it was Maharishi Kannad who said that if we go on dividing the matter, we get tiny particles, very small particles known as atoms. Around that same era, Greek philosophers Democritus and Leucippus also suggested same theory as Maharishi Kannad. So Maharishi Kannad said that there is something called as atoms. So same thing was put forth by Democritus and Leucippus. But why was it not approved? Because all this was based on philosophical consideration. Now if you want to prove any theory that you have put forth, then you need scientific basis for it. You need research papers or experimentation to prove the theory that you have put forth. But neither Maharishi Kannad nor Democritus and Leucippus were able to prove it that matter were made up of tiny particles known as atoms. That's why it was disapproved. Antoine L. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. Here Antoine L. Lavoisier, he put forth two important laws of chemical combination. And the two laws of chemical combination were established after much experimentation by Lavoisier and Joseph L. Proust. I told you previously that any theory that you put forth needs a lot of experimentation and paperwork. Here, the chemical combination laws were established by a lot of experimentation, and finally it was established by Lavoisier and Proust. Let's study the laws of chemical combination. Law of conservation of mass. Mass can neither be created nor destroyed in a chemical reaction. This is the law of conservation of mass. This means that during a chemical reaction, the sum of the masses of the reactant and products remain unchanged. To put it in simple words, suppose let us assume A and B are the reactants. The total mass is about 5 grams. And the new product that is formed, the mass of the product that is formed will also be 5 grams. So what do you understand? That means mass can neither be created nor destroyed. The masses of the reactants and the product will remain unchanged, or it will be the same. Experimentation to prove that law of conservation of mass. Let's look at the activity. Take some sodium sulfate solution in a conical flask and some barium barium chloride solution in an ignition tube. Now if you look at the first diagram, we see that in the conical flask, barium chloride solution, sodium sulfate solution is taken in a conical flask and barium chloride solution is taken in a test tube. Now you are taking this test tube and you are placing it inside the flask using a thread that is tied to the cork. Okay, the thread is not only attached to the test tube but also tied to the cork, okay, and kept it in a tilted manner. Now once this setup is done, we are finding the mass, and the mass is 300.23 gram. Once this is done, what do? Then we tilt the flask. When we tilt the flask, what happens is sodium sulfate and barium chloride get mixed up. So a reaction is taking place. I think this is clearly visible in the second picture. Here the flask is tilted and even the test tube is also tilted. So what we see over here is there is a reaction that is taking place, and finally after the reaction has taken place, we can see the mass has remained unchanged, that is 300.23 grams. So the mass has remained unchanged. Find the mass of the flask on a balance, then tilt the flask. A chemical reaction takes place and sodium chloride and barium sulfate are formed. Find the mass of the flask again. It will be seen that the sum of the reactants and products remain unchanged. So this is one experimentation to prove the law of conservation of mass. Law of constant proportion. It states that in a chemical compound, the elements are always present in a definite proportion by mass. Now what do I mean by this statement? Let's try to understand this with the help of an example. Water, H2O. It always contains two elements of hydrogen and oxygen combined together in the same ratio, that is 2:16, or if we simplify it further, we get 1:8 by mass. You take any water sample from the pond, okay, from the river, you take any water sample, the hydrogen and oxygen combines in a fixed ratio. And what is that ratio? It is 1:8. It is 1:8. It will not combine in 1:3 ratio or 1:4 ratio. It has got a fixed ratio in which it combines, that is 1:8. If 9 gram of water is decomposed, or we try to break down this 9 gram of water, we will get 1 gram of hydrogen and 8 gram of oxygen. It simply means that whenever hydrogen and oxygen is combining, it is combining in a fixed proportion or a fixed ratio, and that ratio is 1:8. Same thing with ammonia. When nitrogen and hydrogen is combining, and it is combining in a same ratio, fixed ratio, and that ratio is 14:3. It will not combine in any other ratio. It has got a fixed ratio. Moving on to Dalton's atomic theory. Matter is made up of tiny particles called atoms. Atoms are indivisible and cannot be created or destroyed in a chemical reaction. So, according to Dalton's theory, we cannot divide the atom further. But we know at present that atoms can be further divided. And atoms cannot be created nor destroyed in a chemical reaction. Atoms of a given element are similar in mass and properties. If I take sodium element, it is made up of sodium atoms. The sodium atoms are all similar in mass as well as properties. Next, moving on to the fourth. fourth theory, that is atoms of different elements have different masses and hydrogen. For example, water. Hydrogen has a different property and oxygen has a different property. So we see that atoms of different elements, they have different mass. Their masses are also different and properties are also different. Atoms combine in small whole number ratios to form compounds. Now, according to the law of chemical combination, we saw that whenever atoms combine to form compounds, it combined in a fixed ratio. Water, it combined always in the ratio 1:8 to form a compound. Apart from that, it will not combine in any other ratio, and it was a whole number. In a given compound, the relative number and kind of atoms are constant. When I say relative number, it is nothing but the molecular formula. For example, ammonia, the formula is NH3, that is a relative number. So in a given compound, the formula and the kind of atoms are constant. When I say NH3, it is made up of just nitrogen and hydrogen. There are no other atoms that are present in ammonia. So the kind of atoms are constant and their molecular formula is also constant.